It all begins with an idea that sounds almost unreal. Not a repair, not a modified machine, but a fully homemade jet ski built from the ground up with nothing more than vision, patience, and determination. For months, the work happened quietly behind the scenes. Endless sketches, measurements, experiments, and late nights spent solving problem after problem. Every small detail had to be figured out from scratch. Not only how to make it function, but how to make it feel like a real high-performance watercraft. And now, after all that planning, the build finally begins. What makes this project even more exciting is that it may be one of the first fully scratch-built jet skis ever documented from start to finish. The hardest part wasn't only the engineering, it was the design itself, getting the proportions right, creating smooth, aggressive lines. The foundation that will determine how the jet ski performs on the water. Strength, balance, stability, and speed all begin here. To assemble the frame, polyurethane adhesive is used on every joint. As it cures, the glue expands slightly, filling tiny gaps and locking the structure together with incredible strength. These connection points are critical because they carry much of the stress once the craft hits the water at speed. The overall design draws inspiration from the sleek shape of a modern Yamaha wave runner, especially the flat-bottom hull design known for quick planing and stable handling. It's a practical choice that gives the homemade craft a strong performance-oriented starting point. Next come the ribs, the structural pieces that define the flowing curves of the hull. These components act like the skeleton beneath the skin, revealing how the jet ski's shape will flow from nose to tail. With the framework complete, it's time to close the hull using pre-cut 9mm sheets. The first panels slide into place surprisingly well, instantly transforming the open frame into something that finally resembles a real jet ski. But the tighter front curves quickly become a challenge. The wood must bend sharply to follow the aggressive shape of the bow. Slowly and carefully, the panels are worked into position until they finally sit flush against the frame. Little by little, the machine begins to reveal its final form. Instead of forcing oversized sheets into difficult areas, smaller template-based sections are used throughout the more complex parts of the hull. Each piece is custom-shaped beforehand, allowing the curves to stay smooth and natural without putting too much stress on the material. It takes longer this way, but the cleaner finish and improved accuracy make it worth the effort. Once the outer skin is fully installed, polyester fiber filler is worked into every seam and joint. This step not only seals gaps, but also strengthens the structure and smooths out imperfections across the surface. Fiberglass cloth is then laid across the entire surface. Resin is rolled carefully into the fabric, soaking through every layer and bonding tightly to the wood underneath. As the resin spreads, the fiberglass turns transparent and hugs every curve perfectly. After curing, the hull becomes dramatically stronger, while also gaining a waterproof outer shell capable of handling real conditions on the water. Next come the stabilization strakes mounted along the underside of the hull. These features play a major role in high-speed handling by controlling water flow beneath the craft. After being fiberglassed into place, the entire hull is coated in marine-grade paint. The finish seals the structure completely while giving the project a clean, professional appearance. Before moving further, a dedicated stand is built to safely support the hull during the rest of construction. Some parts were missing from the original templates, so measurements are carefully recreated using a separate dimension sheet. The stand itself is simple but sturdy, built purely for function. Once the hull is lowered onto it, everything changes. The project suddenly feels more real, sitting securely at a comfortable working height, ready for the next stage of the build. Now attention shifts toward the upper structure. The outer ring is recreated once again, this time slightly smaller to leave a clean recessed edge around the perimeter. That small detail will help future panels align properly and give the finished jet ski a sharper, more professional look. From there, the entire project starts fitting together almost like a giant puzzle. One section after another locks into place. The front assembly is installed first, and surprisingly, everything lines up smoothly. At this point, the homemade jet ski is no longer just an idea or a sketch on paper. For the first time, it truly begins to look alive. After that, the focus shifts toward the seating area and the rear framework, the section where the project suddenly starts looking less like scattered parts and more like a real machine. Piece by piece, the structure comes together until unexpectedly, the entire upper frame is complete. The final step in this section is adding two reinforced rails that will support the seat. Beneath them, the interior is intentionally left open. That space needs to stay accessible for the engine, fuel tank, jet drive, and all the mechanical systems hidden underneath. It's practical engineering, but it also leaves everything exposed and unforgiving. Once the machine is running, there won't be much room for mistakes. Small openings remain in some areas, but that's intentional. They're later filled with reinforced polyester filler that strengthens the structure while blending the surfaces together seamlessly. Then comes another long round of sanding, and then more sanding after that. This stage is where handmade builds either begin to look professional or completely fall apart. Every uneven edge, ripple, or imperfection suddenly becomes impossible to ignore. The surface has to be worked over repeatedly until everything feels smooth and consistent to the touch. Once the shaping is finally complete, The entire structure is fiberglassed again. Layers of resin and cloth lock the surfaces together, strengthening the hull while sealing everything beneath a rigid composite shell. Before paint can be applied, the body receives a full coat of epoxy primer. This step is critical because it seals the surface, protects the material underneath, and creates the perfect foundation for the final finish. Then finally, the color goes on. For the first time, the project stops looking like raw construction materials and starts resembling an actual watercraft. The smooth painted surface gives the jet ski a clean, finished appearance, even though underneath it's still a completely handmade machine built from scratch. And that's the part that makes the entire project exciting. Because once speed, vibration, and water pressure come into play, weak points don't stay hidden for long. Next comes one of the most technical stages of the build, fabricating the aluminum components for the jet propulsion system. Every template is first glued directly onto aluminum sheets before the cutting begins. Using a jigsaw fitted with a metal blade, the pieces are slowly shaped one by one. Aluminum is relatively soft and manageable, but accuracy here matters tremendously. Even small errors can throw off alignment later. After all the pieces are trimmed and cleaned, the forming process begins. Some sections need to become smooth cones and curved transition pieces for the intake system. Normally, this type of work would require professional metal rollers and fabrication equipment. But instead of expensive machinery, a simple homemade bending setup is improvised directly on the welding table. It's rough, it's simple, but it works. With the aluminum shaped correctly, welding finally begins on one of the most critical parts of the entire jet drive system, the intake assembly. This component has to align perfectly because every other section depends on it. If the intake sits even slightly crooked, the entire propulsion system can suffer from poor flow, vibration, or performance issues later on. The intake's job is to guide water smoothly toward the impeller while minimizing turbulence. Proper flow here is extremely important because turbulence can cause cavitation, reducing thrust and damaging performance. At the rear, a circular collar connects directly to the jet pump housing, creating one continuous water pathway through the entire propulsion system. From there, the steering assembly begins to come together. The reduction nozzle focuses and accelerates the water exiting the pump, while the steering nozzle redirects that thrust left or right to control the craft. Mounted around it is the reverse gate, a a mechanism capable of redirecting water forward to help the jet ski slow down or even reverse. At the center of everything sits the impeller and drive shaft assembly, the heart of the propulsion system itself. Now comes the part everyone has been waiting for: the engine. Instead of using a traditional marine setup, the creator chooses something far more aggressive: a superbike engine. Compact, lightweight, and capable of screaming past 12,000 revolutions per minute, this inline carbureted engine produces roughly 180 horsepower. For a homemade jet ski, that's an insane amount of power. It's an unconventional choice, but that's exactly what makes the project so exciting. A strong steel frame is built inside the hull to support the engine. Rubber mounts are added to reduce vibration and stop the whole jet ski from shaking too much while running. Another support is made for the bearing assembly. Everything needs to line up perfectly with the drive shaft and engine, because even a small mistake could cause heavy vibration at high speed. A pillow block bearing is mounted onto a steel bracket to support the spinning shaft and keep the drivetrain stable under load. Instead of a chain or gearbox, the build uses a belt drive system. Wide V-belts and pulleys transfer power from the engine to the shaft smoothly and quietly. Next comes one of the hardest parts: the exhaust system. The original motorcycle exhaust is too large to fit inside the hull, so a custom system is built from scratch using 40mm tubing. For exhaust pipes are carefully shaped and merged into one collector made from a larger 60mm pipe. After that, a water lock system is added. This cools the exhaust, reduces noise, and stops water from flowing back into the engine. Cooling lines are also connected directly into the exhaust to help control heat during operation. Another reinforced frame is built to support the cylinder head and electrical system. A sealed AGM battery is mounted nearby because it can handle vibration in rough conditions. At this point, the homemade jet ski finally starts looking like a real machine. The drivetrain is complete, the power system is installed, and everything is nearly ready to run. The ignition coils are connected, the ignition switch is mounted, the battery is wired up, and the fuel tank is ready. Now there's only one thing left to find out. Will the engine start? Next, the cooling system is connected. Hoses are added to both the engine and exhaust, and a normal garden hose is used to supply water during the first test run. Work then moves to the seat section. Small cuts are made in the plywood so it can bend into shape without cracking. Once the frame is complete, fiberglass is added to strengthen it. Foam padding is glued onto the seat base, trimmed into shape, and sanded smooth. The seat is then wrapped in dark marine blue artificial leather to protect it from water and sunlight. Attention then shifts to the throttle and reverse controls. custom lever system is built inside the cockpit, connected to the reverse nozzle with a cable. When the reverse cap drops over the jet outlet, it redirects the water flow to slow the craft down or move it backward. A ball joint is added to keep the movement smooth. For safety, the system automatically returns to forward mode if the cable ever disconnects. At the rear, a support handle is added for passengers to hold on to during acceleration or rough water. An air vent with a mesh cover is also installed to improve airflow inside the hull. Next comes the rear grab rail. Steel tubing is cut, bent, and welded into shape, then finished with smooth wooden grips to keep the handmade look of the project. Finally, the jet ski is painted. The body gets a white finish with black and blue graphics, while rubber traction mats are added to improve grip on wet surfaces. A rubber trim seal is installed between the upper and lower hull sections to help keep water out. What started as loose parts and rough ideas slowly became a complete machine. After all the cutting, welding, fiberglass work, and testing, the homemade jet ski is finally finished. Now only one step remains, putting it in the water. From simple materials to a fully working machine, this is just one project. Subscribe to Klifs Tech and follow along for whatever gets built next.